Bottlenecks in third-party libraries and plugins is a major source of pain for developers working with Magento, Shopware, WordPress or other customizable, off-the-shelf PHP applications. Moin, I am Benjamin, and in this video I'm going to show how to use Composer patches as a last resort to fixing performance problems in third-party code. I show how to install the Composer patches plugin and an example from Doctrine DBAL that improves Shopware 6 performance. It's a sad but common truth: plugin authors more often than not are not interested in improving the performance of their code. That makes it necessary to sometimes patch the code from third-party plugins, and one way of doing that in projects that are using Composer to install third-party plugins is the Composer patches plugin. You can find an example of using Composer patches to fix performance in third-party libraries on our Tideways blog. There I also link to the Composer patches plugin on GitHub, and the project also has its own website that you can look at with information on the plugin. This is not a primary Composer functionality, but acts as a plugin that is not shipped by the Composer author itself. There's also a huge word of warning that I need to issue about this. Composer plugins has a feature that allows you to load patches from remote sources, for example from a GitHub gist or any other remote URL dynamically during installation of a project. I don't recommend using this remote approach because it's really dangerous to dynamically load code from an unvetted source, especially if the code can be changed at any point in time. You should always use Composer patches in local mode. That means the patches are part of your project and you can vet those patches. Even if you're using patches to change third-party libraries, there's still a word of warning I have to issue. You're obviously breaking all warranty seals and voiding sort of the support of a third-party library that they have tested their code to be bug-free or as bug-free as possible. You should perform your own tests with the patched code to make sure it works as intended. For this video we are going to look at the Doctrine DBAL SQL Parser patch again that I talked about in a previous video. Here we are going to apply this patch to an existing Shopware installation to see how we can make use of Composer patches. Doctrine DBAL is usually a well-maintained library and you can upgrade it using Composer directly. I'm just going to show this to demonstrate how Composer patches can work. Following along my blog post, we see how we can install the Composer plugin. I'm going to copy the installation instructions. Currently, Composer patches version 2 is in beta. That means we need to specify the exact version you want to install. If you're watching this video, maybe check if there's still beta 2, the most recent version, or you need to use a different version to install it. Switching over to PHP Storm, we are entering the Composer command to install this plugin. It asks us if we trust the plugin to execute scripts, and we do say yes. The plugin is going to be installed. When the installation is finished, we add a patch to the library. Let's look over the code of the class that we want to patch again shortly to remind us of what we are doing here. The SQL parser of Doctrine had an inefficient way of parsing SQL statements by running several regular expressions on the string independently over and over again, calling prep match for each individual regular expression. The patch that we are going to apply is combining this regular expression into a single regular expression and using named capture groups to differentiate which of the different patterns was matched at any single point of time when the regular expression was applied. We can grab that patch directly from GitHub, going to the pull request on the Doctrine DBAL repository, appending.patch to the URL. We get the Git compatible patch. I copy this over, go back to PHP Storm. In PHP Storm, I have a patches directory. I create a new patch here, Doctrine DBAL SQL Parser patch. Pasting the code in there. The next step is to modify the composer JSON file. In the extra section, we add a new key patches and we specify which composer library we are going to patch, Doctrine DBAL, and then we specify another key value pair explaining what the patch is about, SQL Parser 3.10 improvement. So in this case, we are pulling along a performance fix into an older version just to get the benefit earlier than updating to the version completely. This could be necessary if the changes from the current version you're on to the version with a fix are too big and they break other things in your application. This way you can partially pull code from more recent versions into your project. Especially for performance fixes, this is a really nice way of applying them as early as possible. To apply this new patch to the project, we run a command that the plugin provides to Composer. So Composer patches, relog, applies all the patches again. After logging the patches, we can look at the patches.log.json to see that the Doctrine DBAL patch that we applied was registered. We then run Composer patches repatch without scripts, and it will uninstall Doctrine DBAL, reinstall it again, and then apply the patch to have a clean version. We can see that here. And after it has optimized the autoloader, we can go back to the parser.php and see that the code has changed to the code from the patch. It includes the token pattern with the named capture groups now, and the code in parse is much simpler, just executing the prag match with this combined token, and then based on the named capture group calling different methods on the parsing visitor. And this will improve the performance of this API quite a lot, because there are just so much fewer functions being called, and those functions that are called, like prag match, are not called multiple times anymore on each different patterns, but using this combined pattern. Let's quickly look at the call graph to see how this change affects real-world shopware installation. We are searching for the parser parse method in the call graph data, and in a request that was before the patch, this took 24 milliseconds, and we can look at all the methods being called here. The closure that delegates to the visitors is quite expensive, but we can also see multiple different prag match calls here, as well as the calls to key and current that are necessary to control how the while loop worked in the previous code. Let's compare this to a trace afterwards. I've generated one in preparation before here, and looking at a difference of both traces, again using the parser parse method, we can see that in the improved request it took 10 milliseconds less, meaning from 24, 10 milliseconds, almost 50% improvement. And if we look at the changes here, we see there's a new method call for the prag match with the named capture groups. This preg match takes 2 seconds and it replaces 3 preg match calls that we had before for again also almost 2 seconds individually. So we have an improvement here. Then we don't need to call key and current anymore. Also, we don't need to call the closure anymore. Instead, the new code calls directly the visitor methods except other, except name parameters. And because the indirection of the closer is gone, this also improves the code a little bit. If you're interested in more detail on how to combine regular expressions and use named capture groups, you can watch this video here on our channel explaining the SQL parser improvement in detail. Or watch any other video on our channel on topics of PHP performance improvements. Thank you very much for watching.